Are your data clusters falling apart? Today we reveal why UMAP is the superior choice over t-SNE for preserving both local neighborhoods and the global map of your high-dimensional data. While t-SNE is famous for capturing local similarities between points, it often fails to maintain the broader relationships between large groups of data in your high-dimensional space. In contrast, UMAP is designed to preserve both local and global structure, ensuring that similar points stay close, while the overall arrangement of groups reflects their original relationships. Research published in Nature Biotechnology confirms that UMAP is preferable because it offers better consistency across runs and a more reliable representation of the data's true topology. When dealing with datasets containing tens of thousands of dimensions, UMAP's efficiency remains stable, whereas t-SNE's computational cost increases dramatically, making it impractical. This superior performance leads to clearer segregation of samples from different biological groups or batches, providing much more insightful visualizations for complex analysis. Ultimately, if your goal is a clear map of the entire dataset rather than just isolated clusters, UMAP provides the robust, scalable solution that modern data science demands. To see these concepts in action, try our UMAP visualization calculator today. Which visualization method has improved your own analysis the most? Let us know in the comments.